Today's lesson is about the order of operations. We're going to use PEMDAS or GEMDAS to solve numerical expressions that have multiple numbers, multiple signs, and multiple symbols. Let's get started. A numerical expression is just a problem that has more than one digit or number with signs and grouping symbols around them. The way you solve those is with key term number 2, the order of operations. Most of you guys know that as PEMDAS. We're going to replace the P with a G this year because in the past you've only used parentheses. This year we're going to introduce you to more types of grouping symbols. So, the order of operations does have 6 letters in it. However, it is only 4 steps long. So, step 1 of the order of operations is P or G. What you've learned in the past is that the P stands for parentheses. This year we're going to use the G as grouping symbols. And in the special rules column, you'll notice that there are several types of grouping symbols. Like I said, you've used parentheses before, but there are also brackets and braces. Those follow the same rules or serve the same purpose as parentheses. Absolute value signs are actually grouping symbols, and then a fraction bar is a grouping symbol. So you're going to see how you use those together in problems. You may be asking yourself, why don't we just use parentheses all the time? It has to do with when you have one type of grouping symbol inside another. Using different symbols avoids confusion for the grouping symbols. So you solve all of those first. The next step is exponents, E. We just finished a lesson on exponents, so you guys should know how to solve all of those. So you'll solve any exponents in the problem. Okay? We have 2 steps left with 4 letters. And that's because a couple of letters go together in each step. So the third step actually includes M and D, and that's multiplication and division. So when do you do which type of operation first? Do you always multiply first? Do you always divide second? The answer to that question is no. You solve these from left to right. So what that means is if you see division in front of multiplication in a problem, you divide before you multiply. You do not always multiply first. Okay? The fourth step is the last one. That includes the last 2 letters, A and S. That's for add and subtract. You do the same exact thing with adding and subtracting that you do with multiplying and dividing. You solve them from left to right. So you don't always add before you subtract. You solve whichever one comes first, just as if you were reading a book. Okay? So we're going to do some practice problems now to use our order of operations. What I suggest doing is writing down PEMDAS or GEMDAS on your paper and crossing out the letters as you go along. I'm not going to do that here. That might be a good strategy so you don't skip steps. Okay? So if you look at this problem, the first thing that you should see is there are no parentheses or grouping symbols, and there are no exponents. So we can skip those 2 steps. There is division though. So we have to use our order of operations to divide before we add. Division comes in step 3, adding comes in step 4. So we'll divide first. So 15 divided by 5 gives you 3. And this 3 and the plus sign just drop down to the next line. For step 2, there's only one operation left. We have to add. 3 plus 3 is 6. So the simplified version of this numerical expression is 6. Pretty simple problem. Now let's go on to problem number 2. If we go through our order of operations, we'll notice that there are no parentheses or grouping symbols. There are no exponents again, but there is division and multiplication. So even though we memorize the order of operations as PEMDAS or GEMDAS, the division problem in this numerical expression actually comes before the multiplication problem. So we have to do that first. So we're going to divide first, okay? So we go from left to right. So the first thing we do is we write down the rest of the problem, except we solve the 21 divided by 3, and that's how we got 7 right here. Okay, we're going to continue with step 3, which is the multiplying and dividing, because there is still multiplication in the problem. So the next step is to do the 7 times 4 to get 28. And again, you notice I'm writing the rest of the problem around what I'm solving. I'm just recopying and recopying and recopying. This is how you have to show your work during class. Okay? The next step is the adding and subtracting step. That's step 4. So what you'll notice here is that subtracting comes before adding. So we have to do 28 minus 28 first to get 0. And then we can do our last step, which is 0 plus 5. 0 plus 5 is equal to 5, and that is our solution. Okay, example number 3. This one looks like a shorter problem, but it's got some new stuff in it. There are no grouping symbols yet, but there is an exponent. We just finished solving exponents in the last unit. So what you should know is that 3 to the second power is not 6, it is 3 times 3, which equals 9. So we solved the power and got 9. That was our first step. For step 2, or the next step in the problem, we went through E, so the next step would be multiplying or dividing. And there is multiplying in this problem, 9 times 4, so that's the next step. We're rewriting the rest of the problem around it, so the 2 got brought down, and the 2 will get brought down again. 9 times 4 is 36. The last step is to do your addition. And 2 plus 36 is 38. That is your solution. Okay? Next problem, more practice. This one has some negative signs in it, so we're going to have to use our integer rules for this problem. There are also grouping symbols. So we're going to start with step 1 in our PEMDAS or GEMDAS table, and we're going to do grouping symbols first. Inside the grouping symbols, what you'll see is negative 3 times 4. Negative 3 times 4, remember when there's different signs when you multiply, you get a negative answer. Negative 3 times 4 is negative 12. What you'll notice is that I kept the parentheses around negative 12. The reason I did that is because I wanted to separate this subtraction sign from this negative sign. We wrote most of our problems in the integers unit just like that. Okay? So they're separated. If this was a positive number and not negative, I wouldn't necessarily need to keep those parentheses there. I could, but I wouldn't necessarily need to. Again, what you'll notice is that I recopied the rest of the problem around what I solved. And now I'm going to look to see what the next step is. I have subtracting left, 42 minus negative 12, and then I have division left. Division comes first, so I have to do dividing next. Negative 12 divided by 6. When you divide different signs, just like when you multiply different signs, you get a negative answer again, so that equals negative 2. And now I have one problem left to do. The last problem is 42 minus negative 2. So I have to use my subtracting integers rule to solve this. I use the rule keep, change, change. So I change this to addition. I change this to a positive number. And I add. And 42 plus positive 2 is 44. And that is your solution. Okay? Next one. This one has a bunch of grouping symbols in it. What we remember from the table is that a fraction bar is a grouping symbol. Parentheses are grouping symbols. And this also has brackets. So the first thing we have to do is solve the numerator and the denominator independently of each other. After we do that, the division, that's what the fraction bar shows, division is going to happen last. So let's solve the numerator first. So we have to solve the numerator one step at a time, then solve the denominator. The fraction bar tells you to divide the two numbers when you are finished with each part. So let's start with the numerator, okay? Work inside the innermost parentheses first. So I have to start inside the parentheses and work my way out from there. So I'll solve the parentheses, and then whatever's in the brackets I'll solve. I'll do the exponent, because the exponent's outside of the brackets. And then I'll do my denominator, and then I'll divide those two numbers. So inside the parentheses, what you'll notice is that the first thing I did was 4 times 5, because multiplication comes before subtraction. Okay. After that, I did the subtraction and get 26 minus 20, and that equals this 6. Okay. Those parentheses that were around that problem disappeared because I don't need them anymore. What did not disappear is the brackets, because I still need the brackets. There's still this other plus 6 I brought down over here inside the brackets that I need to add to the first 6 before I use the exponent. So step 2 is to work inside the brackets. They're used as a second grouping symbol. So 6 plus 6 is what I just did. 6 plus 6 is equal to 12. And now I can finish the numerator by doing the exponent. Solve the power. 12 to the second power is 144. So I solved my numerator. Now I have to solve the denominator. So let's do that. This is a one-step denominator, 2 times negative 6. 2 times negative 6 is negative 12, so that's what I just solved, this problem right here. And now after I have that, I have a division problem. I can divide the numerator by the denominator. A fraction bar is a division sign. So 144 divided by negative 12, think about your times tables. We know that 12 times 12 is 144. So if I do 144 divided by 12, I get 12. Since I have one positive number and one negative number, the answer is going to be negative. So the answer is negative 12. Okay, that's it for the lesson. I hope you guys enjoyed, learned something. Feel free to rewind, rewatch, and use for your homework, and I'll see you next time.